Hello student, I am Dr. Chandrasekhar. I am going to teach you there are two unit. One is polarization, another one is the laser. Before start the laser, first thing we need to tell about something about the light. Light, all of us know students. First, wave theory. The 16th century Christian Huygens, he proposed the wave theory, but it could not explain some of the light principles. It is followed by 17th century Sir Isaac Newton proposed the corpuscular theory. Now this is again it could not explain the sum of the light principles. Now later on James Clerk Maxwell's the 18th century gave the electromagnetic wave theory. Later on 19th century Albert Einstein he gave the matter interaction with the radiations. Now this is followed by uh, the word laser is acronymic for light amplification by stimulated emission of radiation. It is basically an optoelectronic device. And the most interesting invention of 20th century, the field of applied optics, the first ever known laser system was built by H. Myman. Now students, here some of the characteristics of laser. All of us knows the laser, it having monochromatic, that means it having single wavelength, coherent, it having same phase and same amplitude, polarized. In case of laser light is easy to pass in the media, high directionality, then high intensity. These are all the some characteristics. Now student, I will take the general difference, that is incandescent bulb and laser light. All of us knows this is the bulb, this is the laser light. In the bulb, it having many wavelength, multidirectional, incoherent. The photons, this also emits photons, but these photons it fade only little distance. But as compared to the laser, it is monochromatic, high directionality, coherent one. Here, this emitted photons, it moving, it does not fade in little distance. Now, student, come to the laser topic as per your syllabus. There are three basic principles. One is induced absorptions, spontaneous emissions, stimulated emissions. We will discuss one by one. Now, these principles based on the radiation interaction with the matter. Student, now here before absorptions, this is the after absorption. There are two diagrams. Now, first student, let me know about the this is ground state, this is excited state. Here already I told you this is purely depends on the radiation interaction with the matter. The radiations it having photons, the matter it having atoms. I used to say the radiations imping on the atoms, that is the matter radiation interaction. Student, now induced absorption case, in the photon is interaction with the ground state atom. After certain times this ground state atom goes to the excited state. Now this mechanism is used to called as induced absorptions. Now take the second one, that is the spontaneous emissions. Student, spontaneous emission case. Now this is before emissions, this is after emissions. In the before emission case, here E1 is the ground state, E2 is the excited state. When the excited state atoms already in the excited state, here it will be a transition takes place from excited state to the ground state. In the excited state here, these atoms stay only short time. Within short time, it will be come back to the ground state. During that times, it emits some amount of energy, that is the photon. We can calculate the energy, the difference between ground state and excited state, that is h nu is equal to E2 minus E1. This h nu is the photon energy. Now students, generally the spontaneous emissions, it will be occur in the LED bulb and ordinary incandescent bulbs. Now these are all the mechanism it will be happen. Now let me move to the stimulated emission case. In the stimulated emissions case, here student, this is again before emission, after emissions. But here the excited state atoms interact with the radiations. In the previous case, it doesn't interactions with the radiations. Itself, it will be come back to the ground state in the previous case. But here, the radiation interaction with the excited state atoms, then it will be transition takes place from the excited state to the ground state. Some amount of energy it will be emits. Student, now this is, it is the principle of laser actions, because here stimulated emission it will be happens. Okay. Now this is the basic principles of lasers. Now these are all the 2-level systems. Now let me move to the 3-level system. Student, here 3 levels: E1, E2, E3. These are all the 3 states. E1 is the ground state, E2 is the metastable state, E3 is the shortly weighted state. Now student, here in the 3-level systems, first we need to understand the when the radiation interaction with the ground state atoms, then it will be transition takes place from the ground state to the shortly weighted state. After a few seconds, the shortly weighted state to the metastable state transition takes place. But during that times, there is no radiations, it will be emission takes place. Here, in this shortly weighted state, the excited atom, it will be stay only few seconds, that is 10 to the power of minus 9 to 10 to the power of minus 6 seconds. When the excited atoms, it will be come back to the metastable state, that is the E2. Here, now student, we will say some numbers. N1 is the represent the number of atoms present in the ground state. N2 is the number of atoms present in the metastable state. N3 is the number of atoms present in the shortly weighted state. In these 3-level systems, first we need to understand population inversion. This population inversion is the one of the conditions for the laser actions. Here, the population inversions occur between the excited state and the ground state. Now, in these mechanisms, we used to take the excited state as the metastable state, that is E2 and E1. Here, number of atom N2, that is E2, is more than as compared to the ground state. This mechanism is called as the population inversions. Once the population inversion achieves this state, then only laser action takes place. This is the one of the conditions. The second condition is the metastable state. Student, now let me move to the Ruby laser. The Ruby laser was first built by scientist H. Myman in the year 1960. In the Ruby laser, it consists of 3 parts. One is active medium, optical cavity, then energy source. Student, here energy source usually used as a, which is the Ruby laser, which is also called as the solid state laser. Now we will take the first is the constructions. Now there is a flash of tubes. In this flash of tubes, that is the helical shape xenon flash of light, it will be emits. Student, come to the Ruby rod here, which is in the order of 10 mm. In this Ruby rod, it consists of 2 elements, one that is Al2O3 and chromium atom. Generally, they have to use for the chromium atoms because this is very active as compared to Al2O3. Here, in this Ruby rod, one end is the fully reflecting surface, the another end is the partially reflecting surface. Now, these are all some constructions about the Ruby laser. Students, this is in the flash of xenon light, it will be emit some radiations. The radiations interaction with the matter, that is the Ruby rod, that is the chromium atom and Al2O3 atoms. Here, some transition takes place from ground state to some other states. Afterwards, after emissions, there will be a multiple reflection takes place. That's why they have to place the 2 mirrors on either side of the rod. This is the fully reflecting mirror, this is the partially reflecting mirror. Once the light, it will be a transition takes place from left to right, right to left, like this. Once it will be reaches its intensity, then only the partially reflecting and the laser light output will be coming out. Now this is the construction for student. E1 is the ground state, E2 is the metastable state, E3 is the excited state. Now when switch on the energy source, it emits a xenon flash of light. Xenon flash of light, it contains some radiations which will interact with the chromium atoms. Before interactions, the chromium atoms occupied in the ground state. When the radiations and the atom interaction takes place, that atom is chromium atoms. The chromium atom, it will be transition takes place from ground state to the excited state. This excited state, which is also called as shortly emitted state. Here, the excited atom, stay here only few seconds, that is 10 to the power of minus 9 to 10 to the power of minus 6 seconds. Afterwards, the excited atoms to metastable state, there will be transition takes place, but there is no emission takes place here. Afterwards, in this metastable state, the atom stay 10 to the power of minus 6 to 10 to the power of minus 3 seconds. Now we can compare here. Atoms stay here in the metastable state more time as compared to this excited state, which is also called as shortly emitted state. Already I told you. Then these excited atoms to ground state. Now here, when the laser, it having some conditions, that is population inversions. After achieving the population inversions, then only the laser light output it will be coming out. That means the number of atom in the excited state is more as compared to the ground state. Here, when the radiation interaction takes place to the ground state, the chromium atom decreasing trends. In the metastable state, it will be excited atom more time as compared to this state. That's why the number of atoms occupied in the E2, that means metastable state, is more as compared to the ground state. That means that is the population inversions. After achieving the population inversions, it having two cavities. One is fully reflecting mirror, another one is the partially reflecting mirror. After laser light, it reaches the maximum intensity, then only the laser light output it will be coming out. This is the process. The expected wavelength is 6943 angstroms. Now this is one of the solid state lasers. Now this solid state laser is used for different applications. We will discuss later. Student, the next video we will discuss another type of laser, that is helium neon laser. And today class, the basic principles are important, and ruby laser construction and working both are important. Stay home,